Thank you very much.
Right.
So I'm Morgan. I'm a geochemist and data scientist working at CSIRO Mineral Resources Discovery here in Perth. I'm joining you from the land of the Whadjuk people of the Noongar Nation. And I'm just going to run through an overview of a Python package which I've been building called Pyrolite. I've also been working with Michael on using and making Lambdas a bit more accessible. So you'll see some briefly again here. And if you want to tweet at me on Twitter, you can find me at Metasomite. So what is Pyrolite? Pyrolite is a set of tools which can help you get more out of your geochemical data. It's an open source Python package which is freely available, and you're able to see and suggest changes to the code. It's under active development and eventually aims to be a community-driven project. At the moment, it doesn't have a graphical user interface of its own, and instead it's designed to be used programmatically, allowing you to leverage the scientific Python ecosystem in a fairly flexible way. In the broader view, Pyrolite's about encouraging a programmatic approach to geochemical data analysis, where our workflows are more clearly defined, more robust, better documented, and more reproducible. And where we can, we try and make it easy to get into, well documented, and able to run almost anywhere. And we're trying to build a community around it. It's not a silver bullet for your geochemical data interpretation issues, but hopefully can streamline the process a little bit. We did publish a short overview paper of Pyrolite in the Journal of Open Source Software last year, so feel free to check that out if you want a quick overview, but otherwise check out the documentation for a bit more detail and more up-to-date view of things. So when it comes to what Pyrolite can help you do, Pyrolite aims to provide some fairly specialized functionality to complement the general tools which already exist, simply so you can get started with your data faster. And generally the interface is designed around your data and designed to be able to interface with the existing tools there. So Pyrolite includes a range of functionality around transforming your geochemical data, whether it be transforming elemental data to oxides all the way around, looking at mineral compositions, normalizing to reference compositions. And there's a few examples here on the right of some that have rare earth data, but there's a whole bunch more and they're easily referenceable in Pyrolite. And also contains the database of these reference compositions, as well as major element compositions of a range of rock forming mineral end members. One thing which we don't always acknowledge about geochemical data is that it's compositional, and this means that our data exists in a closed system where things sum up to 100%, which introduces some level of spurious correlation and a few other issues. And when we ignore the closed nature of our data, we can end up with a few erroneous statistical measures, especially when working with major elemental data. So Pyrolite includes functions for compositional data transformation to help deal with this, including the commonly used log ratio methods, additive, centered, and isometric log ratios, as well as a few others which are less commonly used in geoscience. And when we look at some of the issues with the naive analysis of compositional data, like biased means, difficulties dealing with nonlinearity related to spurious correlation, and things like just dealing with strictly non-negative values, we can see that log and log ratio methods immediately give us better results. So we get more representative means. We can easily capture that nonlinear variation and look at meaningful trends and principal components. And we can start to deal with some of these issues at low abundances for things like kernel density estimates. And for instances where log ratios don't quite fit our requirements, like where we have zeros in mineralogical data, we can use alternative methods like the spherical coordinate methods, which in this case is simply mapping our ternary diagram here with 3 components onto a spherical octant and transforming our data into angles. And the other core use case for Pyrolite is visualization. So Pyrolite provides methods for making things like ternary diagrams and spider diagrams alongside a few other templates that you can work from. This grid of plots here on the right shows some ways that we can visualize data distributions in bivariate and ternary systems to avoid issues with overplotting, which we're seeing a lot more as our data sets that get bigger and bigger. So we're going from standard scatter plots to density, contour, and heat scatter methods, all of which have a very similar interface. And the interface for creating these plots is designed to be fairly similar to other commonly used tools in Python. So it plays nicely, so you can mix and match, choosing where you use Pyrolite and where you just fall back to other tools. As I mentioned earlier, Pyrolite also includes functionality for parameterizing your rare earth element data through transforming them into Lambdas, which is based on Hugh O'Neill's implementation from 2016, and generally consistent with Michael's B Lambda implementation as well. Some recent expansions to this include the ability to jointly fit lambdas, tetrads, European zero anomalies together with parameter uncertainties. You saw some of that in B-Lambda just before. This is at an latest release and published in this paper with Michael. And when you start working with large data sets, you can start to do some things like this, which is essentially reproducing a figure from Hughes' 2016 paper, where we have Lambda 1, which relates to the sort of linear slope, and Lambda 2 related to the quadratic curvature in these patterns for a database of mafic and ultramafic lavas in Archean greenstone belts, illustrating the range of sort of rare pattern flavors that you see here relative to morb and primitive mantle. So this is from a paper with Steve Barnes, and you'll find an abundance of other Pyrolite derived figures there. But beyond just summarizing rare earth element patterns, lambdas are particularly useful if you want to use rare earth element data for modeling or machine learning, where the multicollinearity and the dimensionality can be a bit of an issue. So chat to me later if you're interested in that side of things. Pyrolite also includes a gradually expanding set of utilities for plot templates and even a geological timescale, which slipped in there. And by providing a range of functionality, some of it which is quite simple, we can start to combine and integrate a few of these different functions in a fairly flexible way. And part of the idea behind Pyrolite is start to make these linkages between tools, data, models a little bit easier. And Pyrolite's providing some methods to user data and some sort of common modeling tools like alpha melts, and also contains some interfaces for linking geochemical data to machine learning workflows. And through establishing these links, the aim is to kind of get more out of our data and essentially put it to work rather than just letting it sit on a hard disk. And the good thing here about Python or even other comparable languages like R or Julia is that they all come with batteries included, and especially for things like machine learning. So rather than building things which stand in isolation, we can sort of start to contribute and interact with an ecosystem of interoperable tools, which is where taking that programmatic approach can make your life a little bit easier if you can get over the initial hurdles. I've just got a few quick examples here, which contain a small amount of code, but just showing what the interface for Pyrolite looks like. So here, as this is a little bit of Python, we're loading in a few libraries, in this case, pandas, which is for dealing with tabular data, and Pyrolite. We read in just a CSV table in this case, and here we're taking out just some oxide abundances from this table, and we're making a ternary scatter plot. So it basically just takes one line to make the plot, one line to load in your data. So the amount of code that you need to write to get to something that's fairly workable can be quite low. We can also quickly access things like data density contouring and combine this with a scatter diagram. So this is essentially the same as the scatter diagram we just made, but changing the points to a bit smaller, so they kind of fade into the back. And we've just generated some 10.50th percentile density contours over the top of this to kind of summarize where the center of our distribution is. And we just customize the color of these lines a little bit. But you can quickly get to quite a usable figure and sometimes quite nice figures in a few lines of code. We can also start to combine some aspects of geochemical transformation, as well as sort of functionality for plotting. So here we've taken some trace element data from our data set. We're normalizing this to primitive mantle, and then we're just making a spider diagram from this where the elements are ordered by incompatibility. So we're going from very incompatible elements to compatible elements. We're setting the opacity, and we're also just setting the figure size, so it's a little bit easier to see what's going on. And we end up with a fairly nice spider diagram, which has been normalized to primitive mantle. And when it comes to lambdas, if you have a data set containing rare earth element data, it can be as simple as one line. So here we're taking our data, calculating lambdas, tetrads, and cerium and europium anomalies. And this will just return a table with each of the parameters, which we can then play with either in Python or you can export it and work with it elsewhere. So for more examples and a reasonably extensive suite of documentation, you can have a look at the documentation site at pyrolite.rtfd.io. So there's a gallery of examples here which explains what Pyrolite can do and provides you with a bit of code to do it. So in most cases, you could basically copy paste and substitute in your data. If you already have Python installed on your computer, you can install Pyrolite with pip. And with the next release, we have to have Anaconda Forge equivalent working so you can install it using the equivalent Anaconda tools. You can find the repository on GitHub, and we also have a public forum on GitHub for general Q&A. And I just wanted to give a shout out to all the contributors listed here on the right.